Hey, welcome back, and moving right along here in Unit 2. Be ready to take some notes. I'm going to get through this lesson as quick as I can, but as you can see, this says Day 1, right? This is a lesson that's actually going to take us a few days to get through because it's just that important and there's that much going on here. So if you have your textbook and if you'd like to follow along, this would be Lesson 4.2 in your textbook. And it's called Simplifying Expressions. Okay, there's actually quite a bit of vocabulary that goes along with this lesson. And again, it really is pretty important that you kind of get used to understanding and hearing and using these terms. That's kind of funny because that's actually the first definition we're going to talk about. But these words that I'm going to be going through here, you're going to hear so often as we're working our way through this unit. So the sooner you can get comfortable with this vocabulary and understanding what a coefficient is, understanding what a constant is, the better off you will be. Okay, so I always encourage you to take some notes and let's roll, right? Let's get this thing going. First definition is, what is a term? A term is basically a part of an expression, or I like to think of it as a piece of a math problem. So I'm looking at this problem here written in red, right here, and currently the expression says 3x plus 7 plus x plus 2. That expression has 4 terms, and I will circle them right now. 3x is the first term. That's a positive 3x. The next term is a positive 7. Notice how I included that plus sign with the 7. Although it does say plus 7, that is actually, as far as we're concerned, a positive 7. That's how you're going to hear me talk about it. The next term is a positive x or a plus x. And then the last term, the last piece of this expression is a positive 2. So now I have circled the 4 terms in that expression, the 4 pieces of that long math problem. Those are terms. All right? The next word, it sounds like such a really smart math word. It's called coefficient. Coefficient. A coefficient is actually a really fancy word for a very easy idea. And what a coefficient is the number that's attached to the variable. Now remember that variables are letters of the alphabet. So a coefficient is when there's a number stuck on to the letter of the alphabet, right, to the variable in the problem. So I'm looking here at the first one, 5y. 5 is the coefficient because that is the number that is stuck on to the variable y. That's easy, right? 5 is the coefficient. Ooh, look at the next one, m. You might think, well, there isn't a coefficient on the m because I don't see a number stuck on to that m. Well, we've been over this, and this is a case of the invisible one. There is always a coefficient on a variable. Even if you can't see it, it's there. It's the invisible one. So in this example, 1 is the coefficient. How about this next one where it says negative a? That's a negative 1a. So negative 1 would be the coefficient on that term. So once again, coefficients are the numbers that are stuck on to the variables. Constants. These are even easier yet, but we don't usually call them constants. Constants are simply numbers without variables, plain old numbers in a problem. 3 is a constant, 10 is a constant, negative 2 is a constant, 7, negative 45. Oh my goodness, I could go on and on and on and list an endless amount of constants. Constants are just those plain old numbers that you'll see in math problems. They don't have any letters stuck onto them or anything like that. But they're still important, and you still need to understand that we're going to be referring to them as constants in this lesson. Oh boy, here we go. This is where the fun starts. Now we have what's called like terms. Okay, Here's the actual variable. Not the variable, the definition. Like terms are terms that have the exact same variable, has to be the exact same in every possible way, or like terms have absolutely no variable on them. So I've listed some examples of like terms. 2m and 5m are like terms because they both have the exact same variable, and the variable that they have is the letter m. Z, which is a 1z, and 2z are like terms because they both have the exact same variable, and the variable there is the z. And 7 is a like term with 10. These are constants. They fall into the no variable category. Because they have no variable, they're just plain old numbers, they are like terms. Now, the whole reason that we're talking about all these different definitions is because your whole job today is going to be to look at these long algebraic expressions with all these numbers and all these variables, and you need to be able to find the like terms, like the family members. It's like they have the same last name. They belong together. And once you can identify the like terms, you have to combine them and put them together. And then you have to rewrite your expression. So we aren't really solving problems today. We're just taking problems and making them condensed, making them smaller than they started out. So let's practice with our definitions first and foremost. It says, identify the terms, the like terms, the coefficients, and the constants. Okay, here we go. My suggestion to you, before you do anything, is to circle the individual terms in the expression. So watch, I'm going to circle these things, and I suggest you do the same when you're working on your assignment today. We've got a 3a, we have a positive 2, a positive 5a, a positive 7, and a positive 2m. That's 1, 2, 3, 4, 5 terms. Once you have them circled, it's easy to then list the terms. And I know this seems ridiculous because they are listed right up there, but we're going to list them anyways. Our terms are 3a, 2, 5a, 7, and 2m. That's all I did. I just listed them. Which ones are like each other? Okay, so we're looking for the guys that have the exact same variable or no variable. All right, I'm going to do my like terms in blue. I see a 3a and I see a 5a. These guys are like terms because they both have the a. So 3a goes with 5a. Look what I'm going to do. I'm going to put a little bubble around them so that I know that they belong together. Who else has a like term? Let's see. I see a 2 right here. He has no variable. And the 7 has no variable. They go together. So 2 belongs with 7. They're like terms. And then the last one I see over here that hasn't been partnered up is 2m. He's not a like term because there's no other term in the expression that has an m. So he doesn't get included. He just gets left out. He doesn't have a like term. He doesn't have a family member at the party or in this expression, right? He's there by himself. Okay, let's talk about coefficients. We'll do coefficients in green. Coefficients are the numbers that are stuck onto the letters. So 3 is a coefficient. 2 is not. 5 is a coefficient. 7 is not because there's no letter. And 2 is a coefficient. All right, that wasn't too bad. And constants are plain old numbers with no letters attached. I'm going to do these in black. 2 is a constant, and 7 is a constant. You just took that long expression and broke it down into its different pieces. Let's do another one. This one has some negatives in it. Okay, I'm going to circle my terms. I'm going to circle them in black this time. I've got a 5x, and you know what? I'm going to list it right now. I've got a negative 3. I have a positive 7x. And a positive 4. Fantastic. I have 4 terms. 1, 2, 3, 4. Which ones belong together? Who are my like terms? Let's see. I see I've got a 5x. Not with the negative 3. Yes, with this guy, the 7x. Those guys go together. So 5x and 7x, they are like terms. They have the exact same letter of the alphabet. Now, what have I got? I have a negative 3. He has no variable. And a positive 4. He has no variable. Those guys belong together because they have no variable. Let's talk coefficients. We'll do those in blue. Coefficients, numbers that are stuck onto letters. 5 is a coefficient, not negative 3. 7 is a coefficient, and not 4, because 4 doesn't have a letter on it. Constants. Constants are your plain old numbers. 3 is a constant. Oops. Uh-oh. I made a mistake. It's negative 3, isn't it? Uh-oh. And positive 4 is a constant. Okay? Hopefully that helps to further clarify what all those definitions were. Do we have one more? Oh, just one more. Just one more. We're almost done. Here we are. Let's do the terms. Oh, goodness me. I have a 2xy, a positive 6x, a negative 2y, a positive x, a negative 5, ugh, this is a long one, and a positive 3xy. How many terms? 1, 2, 3, 4, 5, 6. 6 terms. Okie doke. Who are my like terms? Who goes together? Oh boy. I start at the left side. I notice I have an xy. Are there any other xy's? Clear here at the very, very end. 2xy goes with 3xy. Remember, they have to match identically, and the xy and the xy go together. Start over in my list. I notice I have an x here. Oh, there's an x there. Those guys go together. 6x and x. Yep. They belong together. I've got a y. Nobody goes with him. And then I've got just a plain old number with no variable. Nobody goes with him. That's it. I'm done with like terms. Coefficients. Numbers that are stuck onto the variables. So I start over in my list. I see a 2 stuck to the xy, so 2 is a coefficient. I see a 6 stuck onto the x. I see a negative 2 on that y. Oh, there's a 1. There's that invisible 1. And a positive 3. Wow, that's a lot of coefficients. Constants. Plain old numbers with no variable. I'm going through my list. I'm working my way across. Oh, there it is. He's my constant. Negative 5. So for now, we're just going to be focusing on identifying the different parts of an expression, figuring out who our like terms are, and then in the next lesson, we're going to actually practice combining our like terms. This is going to take us a few days to get through. We're not going to rush through it because this is really something that's ultra important to understand. Really, truly, for the rest of this year and all through high school. You really need to get comfortable with the different parts of an equation or an algebraic expression. So we're really going to baby step our way through this, all right? So thanks for checking in, thanks for watching, and I will see you in class.